Hey, what's up, Gio? This is Mr. McMorrow here. Going through 1.2 day one here. I want you to take a second here. Why don't you pause the video, and you are going to use the definitions you learned about yesterday and try to come up with the definition, illustration, and naming based off the stuff that's up there and see how many you can do. Time yourself. Make it a challenge for you. So go ahead, pause the video, try to fill it out, and then I'll go over the answers here quick. All right, let's go with point. Well, illustration, pretty easy. All right, so I'm just going to highlight in the different colors. The naming of it, point X or just X. And the definition, it's an object, exact location in space. Okay? All right, now I'm going to switch colors. We're going to talk about what a line is. A line, that's the illustration. Naming it. We'll call it line M because you can use that little cursive letter to name it, just like with planes you can do that. Or you can call AB any 2 points. And it's a flat surface that continues. Wait, hold on. I almost did the wrong one. It's an object, not a flat surface. Flat surface is a plane. All right, so let's go line segment. Line segment. Ooh, I thought I picked red. I'll go with red because that looks too close to the purple. All right, so illustration. Line segment, it's a part of a line consisting of two endpoints. That's definition. And then we would have the segments with no AB with the line segment on top, no rays, no arrows, because if you put arrows on, it's either a ray on one side or arrows on both sides makes it a line. All right, so let's go with a ray. See how that's got the arrow going to the right? That's designating it as a ray. So we would read that ray AB. That's the picture. And then it's part of a line that has one endpoint and goes in one direction. Insert awesome one direction joke right now. Opposite rays would have the same endpoint, so XZ and XY. It has to be both because they're opposite and they both have to have X at the first because that is that's the original point we're going from. So it's X to the left and then X all the way to the right. And that's rays that share a common point. Last but not least is the plane, and that should be pretty easy. That's the illustration. Flat surface that continues in all directions infinitely in all directions, and then we would call it plane ABC, or again, in this case, it has that weird cursive letter. We can call that plane K as well. All right. That idea, too, of naming works with angles. We'll talk about that here in a day or two when we do the videos on naming angles. All right, so that's just a quick review of yesterday. Today we're going to go through and find the length of a segment, and then we are going to use our knowledge of midpoints and bisectors to solve some problems as we go through today and tomorrow with segments. All right, so first off, the distance between any 2 points. Easy way to do it, find out where they're located on the number line, subtract the values. Since we can't have negative distances, that's why in the directions it says right here, take the absolute value of it. So I'll show you what we're talking about. All right, we're going to go from B to C. C is, we're going to say in between 3 and 5, and here's 4. So we're going to say this is 4.5. All right, so we're going to find the distance from 4.5 to 1. So easy way to do that is just do 4.5 minus 1, which is 3.5. Or if you wanted to flip it around, do 1 minus 4.5. That's negative 3.5. We don't like negative values when we're talking distance, so that's when we would use the absolute value and say 3.5. All right, distance from A to B. A is at negative 2. We're going to subtract off B, which is at 1. That's equal to negative 3. We don't like negative distances, so we take absolute value. We get positive 3 for our answer. Flip it around, do it the other way. B is at 1. Subtract off negative 2, because that's where A is located. 1 minus negative 2 turns into 1 plus 2, which is equal to 3. So when you're trying to find the lengths, find out where they're located and subtract the values. If it's a negative distance, absolute value, we always want positive distances. All right. So congruent segments. If we want to say two segments are the same length, which we are right here, we have these two segments. And the reason why I know they're congruent, I don't want to take out a ruler and waste my time measuring, is you just look at these little tick marks. Since they have the little tick marks, that's the reference for you to say, hey, that one that has one tick mark is congruent to the other one that has one tick mark. So PQ is congruent or has the same length as RS. We also do that with angles. All right, we're going to learn this again. So this is kind of foreshadowing. The tick marks are going to be in the part of the angle or the vertex of the angle. Sometimes they'll have little lines on there on those little hash marks too. Okay, so anytime we get to those tick marks, that's meaning same length, congruent. Also works when we start talking about triangles and side lengths of triangles. We're going to have things like this that we're looking at. And what we can say are the ones that have two tick marks, those are going to be congruent. And likewise, the ones that have three tick marks are going to be congruent. So we're going to be looking at these tick marks a lot throughout the entire year. So this is just the introduction to the tick marks, but anytime it's tick marks, showing that they are equal or congruent size lengths. All right, segment addition postulate. I want you guys to write this down. Part plus the part equals the whole. All right, that's kind of like the idea behind what we're doing here with the segment addition postulate. But basically what this is saying is if we have a point, in this case it's B, and it's somewhere in between A and C, doesn't have to be in the middle or not, I would just ask this question right here. What's the distance from A to C? Most of you say easy off the top of your head 8 because the distance from A to B is 3. The distance from B to C is 5. So if I want to find the entire length, I would just add those together. That is the segment addition postulate. You're going to take the two parts, add them together, equal whole. So sometimes you're going to have nice values where we just had 3 and 5. You got to find the whole length. It is 8. Sometimes you're going to have to set up algebraic expressions to find out, solve for x, take that value, plug it back in to solve and find the values of parts of the segment or the whole thing, right? So the word we're focusing in on today is the word between. You can put it anywhere between A and C. Tomorrow we're going to work on what it means to be the middle or bisecting, and that value then has to be smack dab in the middle, and then we're going to say the sides are congruent. But today we're just focusing in on the words between. So draw the picture. Ln is between N and K. L is between N and K. So here's N, here's K. Again, that word between doesn't have to be in the middle. Just has to be somewhere in between. Then it gives you the values. NL is x plus 3, LK is 2x minus 19, and it gives us the whole length of N to K is 23. We have to solve for x. So what we're going to do is we're going to use that concept of part plus part equals the whole. We're going to take the two parts, x plus 3 is a part, and 2x minus 19 is the part. We're going to add those two values together. And then that's going to equal the whole. Now we have an algebraic expression. We can now solve for x. All right, and this is where that first day material, practicing our algebra skills, you're going to do this a lot this year. All right, well, I'm going to combine 2x and x because they are on the same side. So that's going to be 3x. Just like 3 and negative 19 are on the same side, that's going to be minus 16 equals 23. So I just combine the stuff because they're on the same side. Add my 16. 3x equals 39. Divide both sides by 3. 39 divided by 3 gives me a grand total of 13. X is equal to 13. Now you can, if you don't trust it, you can go back and plug it in to make sure we're doing it right. 3 plus 3 gives us 6. And then, 13 plus 3 gives us 16. And then I had a brain fart there, and I was like, wait, this isn't making sense. And then 2 times 13 is 26, minus 19 is 7. 16 plus the 7 gives us the grand total of 23. We know we did it right. All right, do the same thing. B is between A and C. And this is where you have to be careful, because sometimes they try to trick you in the order in which they give you the information. All right, this time they're giving us the whole distance first, the distance from A all the way to C. So it doesn't just go in order. You have to be able to read and locate where that's supposed to go. All right, so AB is 2x minus 1, BC is 11. Those are the two parts. We're going to add them together to equal the whole thing of 3x plus 3. And this is going to be 2x. These two are on the same side, so I'm going to combine them together and get positive 10. And then now we have to practice solving when I have variables on opposite sides, so I'm going to have to add or subtract. Subtract 3, and then x equals 7. And then you can go back and plug that in to see 2 times 7 minus 1 is 13. 13 plus 11 is 24. And then if you plug 7 in here for the whole distance, 3 times 7 is 21, plus 3 is 24. So you know our math is right. Okay, so why don't you guys... There's 3 problems left. Why don't you go ahead and try to do B and C. Pause the video. B, you're going to fly through. C and D will probably take you a little bit of time to get it set up. So why don't you guys pause the video, try these out, and then I will explain them here. All right, so big thing is making sure we know how to label. Y is between X and Z. All right, XZ, which happens to be the whole thing. Because it's X is on this side, goes all the way to Z, that's 8. XY is 3. So to set this up, we have to find Y to Z. 3 plus our question mark is equal to 8. Well, that's question mark is going to equal 5. All right, so that's if they use numbers, straight up numbers, fly through it. Okay, this one, C is between D and E. Well, DC is 1/2 4x plus 6. C to E is 3x plus 1. And then D to E is the entire length. So you're going to do part plus part equals the whole length.
Hello.
How you doing?
Doing good.
Good. I'm going to distribute.
Have a good night.
You too. And then again, we got like terms on the same side, so 2x and 3x is 5x. 3 and 1 makes 4, equal 44. Subtract 4. 5x equals 40. Divide by 5, x equals 8. All right? This one is different. Okay? If you stopped here, great. But now you have to go back through and see what it says to do. It says find the length of DC and C to E. So we actually have to now go back through, plug in 8 in for x. All right? So D to C was 1/2 4x plus 6, which then when we distribute it was 2x plus 3. So now we're going to substitute in 8. 2 times 8 is 16, plus 3 is 19, so D to C is 19. This is what we need to expect your answers to look like. Don't just circle 19 and say that's our final answer. What does that represent? That's the length of D to C. All right? C to E was 3x plus 1. And then we're going to do 3 times 8 plus 1. 24 plus 1 is 25, so C to E equals 25. If you want to just double check your work, the total length was 44, right? The whole length was 44. If you take 19 and 25, add them together, you get 44. We know we did it correctly. All right? Last but not least, B is between A and C. AB is 4x plus 6. So when you get good at this, you're going to see, hey, that's the part. Or if you want to label before you even do it, BC is this piece. That's the other part. So I know I'm going to do 4x plus 6 plus the other part, 7x plus 15, equals the whole of 120. Combine like terms, 7 and 4 make 11. 16 and 15 make 21 equals 120. And then it's just a matter of you subtracting dividing, getting x, and then again the directions say find a to b. AB is equal to 4 times 11 plus 6. Oh, sorry, 9, not 11. 36 plus 6 is 42. That's A to B. And then do B to C, which is 7. Seven times 9 plus 15. 7 times 9 is 63. 63 plus 15 gives you a grand total of 78. Not 178, just 78. Okay? So as you go through and practice tonight, part plus part equals whole. Tomorrow, when you do midpoints, you have to determine if the information is the two equal. Are the two going to equal to each other, or do you have to double it to give it an extra piece and then add them together to equal the whole? Okay? But tonight, just part plus part equals whole. Try out 1, 2, day 1. Have a good night.